Every love song ever written to the moon is a hymn to a catastrophe. Every tide it pulls, a rhythmic memory of an impossible violence. You have seen it your entire life, a constant silver companion etched into our collective soul. It is the metronome of our months, the keeper of our nocturnal secrets, the first world beyond our own that we ever dared to touch. It feels permanent, ancient, a placid, silent witness to the whole of human history. But this serene familiarity is a grand illusion. The truth is, our moon should not be here. Its very existence is a violation, a cosmic anomaly that for centuries stumped the greatest minds who ever dared to ask the question, why? Why is it there? This question is not a simple curiosity. It is a detective story written into the very fabric of our world, a 4.5 billion-year-old mystery whose solution is more dramatic, more terrifying, and more consequential than we could ever have imagined. The solution redefines not just the moon, but the Earth itself. It redefines us. For most of scientific history, we tried to find a gentle answer. We wanted a story of cosmic elegance, a peaceful birth for our celestial partner. Perhaps, one early theory proposed, the young Earth was spinning so furiously, so dizzyingly fast in its infancy, that it simply spun off a great blob of its own molten rock. This fragment, flung into orbit, would have cooled and solidified, becoming the moon in a process we call fission. It's a neat, tidy image, a parent planet birthing a smaller child from its own body. Another idea suggested the moon was a wanderer, a rogue world captured by Earth's gravitational embrace as it drifted through the primordial solar system. This capture theory painted a picture of a chance encounter, a lucky celestial adoption. Or maybe, in the most straightforward scenario, they were simply born together. Side by side from the same swirling disk of gas and dust that formed our sun, they could have grown in tandem cosmic siblings in a shared orbital cradle.
The clockwork mechanism shatters.
A story of quiet, parallel growth, fission, capture, co-formation. 3 elegant hypotheses, each born from logic and observation. And for a long time, they were the best we had. They were our attempts to impose order on the cosmos, to explain our nearest neighbour with a narrative that made sense, a narrative that was calm. But the moon itself refused to cooperate. It held secrets in its silent, dusty plains, and when we finally went there, when human hands first scooped up its soil and rock, those secrets began to scream. The evidence returned by the Apollo astronauts presented a series of shattering paradoxes. There was a collection of clues from a planetary crime scene that accused every suspect, yet cleared none of them. First, there was the sheer size of the suspect. Our moon is enormous. It is not some tiny captured asteroid like the moons of Mars. Relative to its parent planet, it is the largest satellite in the solar system. This brutal fact dealt a mortal blow to the capture theory. Snagging a body that large is not a gentle gravitational handshake. It's a chaotic, 3-body ballet of almost impossible precision. The odds of Earth capturing a world of that mass without it either crashing into us or being flung away into deep space were astronomically slim. The quiet adoption story was beginning to unravel. Then there was the problem of the missing core. The moon, we discovered, is strangely light for its size. It lacks the massive, dense iron core that a world born independently in the solar system should possess. Earth has a giant metallic heart, a churning engine of molten iron that generates the magnetic field protecting us from solar radiation. Mars has one. Venus has one. But the moon's core is tiny, almost vestigial. This strange anatomy made the co-formation theory deeply problematic. If Earth and Moon grew up side by side from the same raw materials, why was one gifted a colossal iron engine, while the other was so profoundly deprived? They could not be simple siblings if their very bones were made so differently. The final, most damning evidence came from the chemistry of the rocks themselves. The theory of a fast-spinning Earth flinging off its own material, fission, had a very specific prediction. The moon should be an exact chemical clone of the Earth's crust and mantle, a piece of the old block. The Apollo samples were put to the test, their elemental DNA sequenced in laboratories across the globe, and the results were baffling. In one sense, the fission theory seemed tantalizingly close to the truth.
Stop it.
The moon rocks and
Nothing
Earth
can
rocks were, in a
outrun
way,
it.
twins. They shared an identical isotopic signature. Isotopes are different versions of the same element, and their specific ratios act like a planetary fingerprint, unique to the region of the solar system where a body was born. The moon's fingerprint was uncannily, spookily identical to our own. This meant they had to have a common origin. They were, without a doubt, family. But this was not the whole story. The rocks told another darker tale. They were bone dry. Not just a little dry, but cooked, desiccated to an extreme degree. They had been stripped of almost all their volatile elements: water, sodium, potassium, zinc, the very materials that are easily vaporized by intense heat. Something had subjected the moon's building blocks to an unimaginable fire, a celestial furnace that had boiled away its lifeblood, leaving behind a sterile, ghostly dust. This violent thermal history didn't fit with the gentle fission process. And what of the Earth's spin? For our planet to have spun fast enough to throw off the moon, it would have had to complete a full rotation in just 2.5 hours. A day that short would leave behind clear geological evidence, a planetary momentum that should still be measurable today, but we find no trace of such a wildly spinning primordial Earth. The physics simply did not work. So, there we were, stranded. Each clue we gathered only deepened the contradiction. The moon was too big to be captured. It was too iron poor to have formed alongside us, and its chemistry was both identical to Earth's and yet violently altered, a combination that the fission theory could not explain. We had journeyed to another world, held its substance in our hands, and the reward for our triumph was a mystery more profound than ever. Our moon was an impossibility, a logical contradiction hanging in the sky. Science needed a new story. It needed a radical idea, something that broke all the rules because the evidence demanded it. It needed a catastrophe. In the 1970s, a new theory began to emerge, born not from a desire for elegance, but from the brutal, messy reality of computer simulations. Two independent teams of scientists, William Hartman and Donald Davis, and Alistair Cameron and William Ward, were exploring the chaotic youth of our solar system. Their models depicted a time not of gentle formation, but of cosmic demolition. The early solar system was a violent shooting gallery, littered with dozens of planet-sized bodies, or protoplanets, on wild, intersecting orbits. Collisions were not the exception, they were the rule. Out of this chaos, they asked a revolutionary question. What if the moon isn't a child, a captive, or a sibling of Earth? What if it is a survivor? What if our world was once too? The idea was audacious, almost heretical. It proposed that about 50 million years after the sun first ignited, the young Earth, still glowing with the heat of its own formation, was not alone in its orbit. Another world was stalking it, a rogue protoplanet, forged in the same neighbourhood of the solar system, sharing that same telltale isotopic fingerprint of home. This other world was a giant. Roughly the size of modern-day Mars, it was a fully formed planet in its own right, with its own dense iron core and rocky mantle. For millions of years, Earth and this planetary interloper would have danced a complex gravitational tango, their orbits slowly, inexorably, drawing closer. The simulations showed the inevitable outcome. There was no future in which they could coexist. Their paths were destined to cross in the most violent way imaginable. We have given this lost world a name. We call it Theia, named for the Greek Titaness, who was the mother of Selene, the goddess of the moon. The theory, now known as the giant impact hypothesis, paints a terrifying picture. Theia, careening through space at over 25,000 miles per hour, did not strike Earth head-on. It delivered a cataclysmic glancing blow, an oblique, world-shattering impact. The energy unleashed in that single moment is beyond any human scale of comprehension. It was the equivalent of trillions of atomic bombs detonating at once, an event so powerful it would have been visible across the solar system. In an instant, Theia itself was annihilated. Its mighty iron core, too dense to be vaporized, plunged deep into the Earth, merging with our own planet's core and enriching it. This explains the moon's lack of a large core. It was stolen by Earth in the collision. Theia's mantle, along with a vast portion of Earth's own outer layers, was utterly obliterated. It didn't just melt, it was vaporized into a superheated cloud of incandescent rock gas, a plume of planetary shrapnel expanding at hypersonic speeds. This explains the bizarre chemistry. The searing heat of the impact, thousands of degrees hotter than the surface of the Sun, was the celestial furnace that boiled away the water and the volatile elements, leaving behind the bone-dry material that would one day form the Moon. The Earth we know ceased to exist. In its place was a hellscape, a world deformed, its surface a global ocean of magma thousands of miles deep. Its day, once perhaps a manageable length, was now whipped into a furious 5-hour spin by the angular momentum of the colossal impact. And surrounding this molten, traumatized planet was a new, spectacular and ephemeral feature, a vast,
Inside the
glowing
Large
ring of
Hadron
debris.
Collider, protons are accelerated
Not a serene
to
ring
nearly
of
the
ice like
speed of
Saturn's,
light
but a
before
churning
entering the
incandescent
collision zone.
torus of vaporized rock, dust, and molten droplets, the combined ghosts of Theia's mantle and Earth's stolen crust. This ring was the crucible of a new world. For a time, perhaps only a few hundred years, perhaps just a few decades, Earth would have looked like a blazing star, adorned with a fiery halo. But gravity is relentless. Within that swirling ring of debris, particles began to collide and stick. Clumps grew into boulders. Boulders merged into moonlets. And through a chaotic process of accretion, these moonlets crashed together, sculpting one another in a gravitational ballet of unimaginable scale. Gradually, one dominant body began to emerge, sweeping up the remaining debris in the ring, growing larger and larger, its own gravity pulling it into a perfect sphere. Just beyond the reach of Earth's fatal Roche limit, where tidal forces would have ripped it apart, a new world was being born from the ashes of the old. Our moon coalesced from the wreckage, not in the cold silence of space, but in the radiant heat of a molten Earth, a glowing white-hot sphere of liquid rock, a child of catastrophe. This is the grand, violent and beautiful story of Theia. It is a theory that, at first glance, sounds like science fiction, and yet it resolves every single one of the intractable paradoxes that haunted us for so long. It explains the moon's size, it explains its missing iron core, it explains its shared isotopic fingerprint with Earth, because it was born from the very same material, and it explains its strange fire-baked chemistry. It even explains the tilt of the Earth's axis, that 23.5 degree lean that gives us our seasons. The force of Theia's blow was so immense it literally knocked our planet sideways, a permanent scar of that primordial encounter. The collision didn't just create the moon, it fundamentally reset the evolution of our planet. It forged the Earth-Moon system as a single dynamic entity. Theia's impact was our planet's definitive moment of creation. It was the day our world was truly born. But a theory this extraordinary requires extraordinary evidence. It is one thing to create this story in the sterile perfection of a computer model. It is another thing entirely to prove it. To prove that a ghost planet, a world lost to time, once slammed into our own. The task seems impossible. How do you find the fingerprints of an event that happened 4.5 billion years ago? Where do you look for the remains of a phantom world that was utterly destroyed? The answer, we believe, is hidden all around us. It lies in the silent lunar dust. It is buried deep within the Earth's own mantle. It is encoded in the gravitational dance our two worlds still perform to this very day. The ghost of Theia is still with us, and now we must begin the hunt. We must sift through the debris of this ancient collision and uncover, piece by painstaking piece, the evidence for the day the Earth had two moons, if only for a moment, before one of them became the other. For nearly all of human history, the question was never how the moon came to be, but who put it there. It was a goddess, a hunter, a cosmic lantern hung in the velvet darkness by some divine hand. It was Selene, driving her silver chariot across the sky. It was Thoth, the Egyptian god of wisdom, a protector against the night's terrors. To our ancestors, the moon was a character in the grand, unfolding story of existence, its rhythms woven into the very fabric of their lives, dictating the tides, the harvests, and the cycles of birth and death. It was a constant, a reassuring presence, and its origin was the domain of poets and priests, not physicists. Yet, as the embers of the Enlightenment began to glow, humanity's gaze shifted. We began to look at this familiar celestial companion not as a deity, but as a world, a place. And with that shift came a question as profound as any ever asked. Where did it come from? The moon, 250,000 miles away, suddenly became the scene of a cosmic crime, an ancient mystery with no witnesses and only one silent piece of evidence hanging in our sky. The search for an answer would lead us down pathways of brilliant, breathtaking imagination, and into one of the greatest scientific dead ends of the modern era. The first truly scientific attempt to write this origin story came not from an astronomer, but from the son of the man who had explained the origin of species. In 1879, George Darwin, second son of the great Charles Darwin, turned his formidable intellect from the evolution of life to the evolution of worlds. He looked at the Earth and Moon not as static objects, but as a dynamic, living system. A parent and a child locked in a gravitational dance that had changed dramatically over eons. He knew that the moon was slowly, almost imperceptibly, spiralling away from the Earth. It was a discovery born from painstakingly analysing ancient eclipse records and the modern physics of tidal friction. If it was moving away from us now, he reasoned, then in the distant past it must have been closer. Much, much closer. Winding the cosmic clock backward, Darwin imagined a primeval Earth spinning at a furious, almost unimaginable rate. The molten sphere turning on its axis not once every 24 hours, but once every 4 or 5. In this primordial frenzy, the planet would have been a flattened oblate spheroid, its equatorial regions bulging outward under the colossal centrifugal forces. Darwin proposed a theory of breathtaking elegance and simplicity. He called it the fission hypothesis. He envisioned this young, molten Earth, already spinning at the edge of stability, beginning to resonate with the sun's own gravitational pull. The planet's surface would have started to heave and fall in a vast planetary tide, a wave of liquid rock sweeping across its globe. With each rotation, this solar tide stretched the Earth further, elongating it until it resembled a colossal spinning pear. The forces became too great. The physics reached a breaking point. In a singular, cataclysmic moment of planetary birth, the narrow end of that pear-shaped Earth tore away. A colossal blob of our world's own mantle, thousands of miles across, was flung violently into space.
This distant corner of the cosmos,
this cosmic projectile, this child of Earth, would have been gravitationally bound to its parent, a ragged, molten sphere of rock that slowly cooled and coalesced into the moon we see today. It was a story of cosmic parturition, a birth so violent it permanently scarred the parent world. For a time, the fission theory was spectacularly successful. It seemed to explain so much. Geologists looking at the globe noticed the immense void of the Pacific Ocean basin. Could this, they wondered, be the scar, the very place from which the moon was ripped? The volume of the moon seemed to roughly match the volume of the missing crust and mantle from that vast oceanic expanse. It was a tantalizing geographic clue. Furthermore, the theory neatly explained one of the moon's most defining characteristics, its remarkably low density. The moon is far less dense than Earth, suggesting it lacks a large, heavy iron core like our own. Darwin's hypothesis provided a perfect answer. If the moon was born from the Earth's outer layers, its crust and mantle, it would have been composed primarily of lighter silicate rocks, leaving the dense iron core of the proto-Earth behind. It was a child made only of its parent's skin and bone, not its heavy heart. For decades this idea held sway, taught in universities and celebrated as a triumph of celestial mechanics, a brilliant deduction that connected the tides we see today with a birth that occurred billions of years in the past. It was beautiful, it was intuitive, and it was almost completely wrong. The cracks in this elegant theory began to appear not in geology, but in the unforgiving realm of physics. The central problem was a concept that governs everything from a spinning ice skater to the orbit of galaxies: angular momentum. Think of it as a cosmic ledger of rotational energy. It can be transferred from one object to another, but the total amount in a closed system must always be conserved. It can never be created or destroyed. For the fission theory to work, the early Earth-Moon system needed a colossal amount of angular momentum, enough for the Earth to spin fast enough to tear itself apart. The problem is, the Earth-Moon system we see today, even when you combine our planet's spin and the Moon's orbit, simply doesn't have that much. The books don't balance. Where did all that extra energy go? No plausible mechanism could account for bleeding off that much excess momentum after the Moon's formation. It was as if a bank account was missing trillions of dollars with no record of any withdrawal. Physicists who reran the numbers found the scenario growing more and more untenable. To achieve fission, the primeval Earth would have needed to spin not once every 4 or 5 hours, but once every 2.5 hours. It's a rotational speed so extreme, the planet would have been on the very knife's edge of disintegration. The forces involved would have been apocalyptic, likely vaporizing the material flung into orbit rather than allowing it to gently coalesce. Moreover, there was the orbital issue. If the Moon was flung from Earth's equator, it should orbit Earth above the equator, but it doesn't. The Moon's orbital plane is tilted by a stubborn 5 degrees relative to Earth's own equatorial plane. The fission model, for all its Victorian grandeur, couldn't explain this baffling tilt. It was a detail, a small inconsistency, but in science such details are where beautiful theories go to die. The scar of the Pacific Basin was also relegated to coincidence, a phantom clue. Plate tectonics, a theory that gained acceptance in the mid-20th century, showed that the ocean floors are young, constantly being created and destroyed, and that the Pacific Basin as we know it didn't even exist when the Moon was formed. The Great Scar was a geological ghost. The fission theory, a child of pure reason, had been slain by a gang of inconvenient facts. With the parent-child relationship debunked, a new story emerged, one not of birth, but of adoption. This was the capture theory. It reimagined the Moon not as a piece of Earth, but as a wandering orphan, a fully formed planetesimal forged in a completely different part of the solar system. In this scenario, the early solar system was a far more chaotic place, a cosmic shooting gallery teeming with rogue worlds on eccentric crisscrossing orbits. The Moon, this theory proposed, was one such wanderer. It drifted through the interplanetary darkness for millions of years until, by a stroke of almost impossible celestial luck, its path intersected with that of the young Earth. It didn't collide. Instead, it approached at the perfect speed, at the perfect angle, on the perfect trajectory to be snared by Earth's gravitational field. It was a delicate high-stakes ballet. Had it been moving a fraction too fast, it would have slingshotted past us, flung back into the void of space forever. A fraction too slow, and it would have entered a death spiral, crashing catastrophically into our planet. But in the capture scenario, it threaded the needle, a gravitational miracle. Its velocity was just right for Earth's gravity to seize it, bleeding off its excess energy and bending its path into a stable, closed orbit. This theory of a captured alien world had its own seductive appeal. It easily explained the differences between the Earth and Moon. The Moon's lack of a large iron core. Simple. It formed in a region of the solar nebula that was iron poor. Its different density and composition were no longer a puzzle, but a confirmation of its foreign origins. It was a foreigner, so it was supposed to look different. The capture theory also offered a potential, though complex, explanation for the Moon's orbital tilt, as a capture event is not constrained to happen along the Earth's equator. For a while, this seemed like a viable alternative, a story of a chance encounter that gave our lonely planet a permanent companion. It painted a picture of a dynamic, unpredictable early solar system where anything was possible. But once again, when subjected to the cold, hard scrutiny of orbital mechanics, this story began to unravel. The idea of a gravitational miracle is not one that sits comfortably with physicists. The conditions required for such a perfect capture are so narrow, so exquisitely precise, that the odds against it are astronomical. It is, for all intents and purposes, a statistical impossibility. Even if you were to grant this miracle, you run into a second insurmountable problem: energy.
Once again, we would
a body
never
the size
see
of the
it
Moon,
coming.
moving fast enough to travel between planets, possesses an enormous amount of kinetic energy. To be captured into a stable orbit, all of that excess energy has to go somewhere. It must be dissipated, and quickly. The most likely mechanism would be tidal forces, the gravitational pull from Earth stretching and kneading the captured moon, generating immense friction and heat. The energy release would have been cataclysmic. It would have heated the moon not just to its melting point, but likely would have vaporized much of its outer layers. The Earth too would have been subjected to unimaginable tidal forces, its own surface likely rendered a global ocean of magma. Yet the geological evidence we have doesn't point to such a globally transformative, high-energy event for both bodies simultaneously in this specific way. The capture theory imagined a delicate cosmic dance, but the physics demanded a demolition derby. There was no gentle way to catch a cannonball this large. The theory was a long shot, an event so improbable it bordered on the supernatural, and as we would later discover, a chemical betrayal was waiting in the wings, a piece of evidence that would prove the moon was no stranger at all. This left a third, more modest proposal, the co-accretion, or binary planet hypothesis. This theory was less dramatic than its rivals. It suggested that the Earth and Moon were not parent and child, nor captor and captive, but simply siblings, twins, born at the same time, in the same place. As the solar nebula, the great disk of gas and dust that would form our Sun and its planets, began to condense, clumps of material started to coalesce under their own gravity. The co-accretion theory posits that two such large clumps formed near each other in the same orbital path. One, the larger of the two, would become the Earth. The other, a smaller but still significant accumulation, would become the Moon. They grew up side by side, sweeping up material from a shared ring of debris around the Sun. The Moon, in this view, was never anywhere else. It was always here, our little sister world forming in our gravitational shadow.
Relentless.
This model solved the energy and
courageous
momentum problems that had
defines
plagued
us,
the fission
makes
and
us
capture
human.
theories. There was no need for an impossibly fast spin, nor for a miracle of orbital mechanics. Their shared angular momentum would be a natural consequence of their shared formation from a rotating disk of material. The process was calm, orderly, and consistent with our general understanding of planet formation. It seemed sensible, logical, the least spectacular, and therefore perhaps the most likely of the three. It neatly explained why the Moon was in a stable, nearly circular orbit around our equator. It had simply formed there. For years, this was the quiet frontrunner, the safe bet in a field of wild speculation, but it harboured a fatal flaw, a quiet contradiction that it could not resolve, and it centred once again on that missing iron core. If the Earth and Moon formed as siblings from the same pool of primordial material, they should be made of the same stuff. They should be, in essence, compositional twins.
The Higgs field
They should both have accreted a
permeates
proportional
all of
amount of all the
space.
elements available in their shared orbital space, including heavy elements like iron. Therefore, they should have proportionally sized iron cores, but they don't. Earth's iron core accounts for about 30% of its total mass. The Moon's core, by contrast, is tiny, making up a mere 1 to 2% of its mass. How could two bodies, forming shoulder to shoulder from the same well-mixed cloud of debris, end up with such a radically different distribution of one of the most common heavy elements in the solar system? The co-accretion model has no good answer. There is no known physical mechanism that would allow the forming Earth to greedily hoard nearly all the available iron while its nearby twin was starved of it. The theory that sought to explain them as twins was ultimately defeated by the fact that they were not identical. They were fraternal at best, with one sibling inexplicably more massive and dense than could be accounted for by a shared upbringing. The quiet hypothesis died a quiet death, leaving behind a profound and unsettling silence. By the middle of the 20th century, on the very eve of humanity's first steps into space, the science of the Moon's origin was in a state of crisis. We had three beautiful, intellectually powerful theories, each born from the minds of brilliant scientists, and every single one of them had failed. Fission was dynamically impossible, capture was statistically miraculous and energetically catastrophic. Co-accretion failed the test of chemistry. It was a perfect scientific impasse. The puzzle was more mysterious than ever. The Moon shared some deep fundamental characteristics with Earth, suggesting an intimate connection, yet possessed profound differences that screamed of a separate origin. It was a riddle wrapped in rock and dust, a paradox hanging in the night sky. The theorists had taken
Within
their
our
ideas as
individual
far as they
lives,
could go from the
these
surface of the
moments
Earth.
are all that matter.
They had debated, calculated
Precisely
and
because
modelled,
they are all
but they had
we
reached the
have.
absolute limit of ground-based observation. The crime scene was 250,000 miles away, and to solve the mystery of its creation, we would have to do the unthinkable. We would have to go there. We would have to leave our world to understand how it came to be and bring back a piece of the moon itself. The truth was waiting, locked away in its ancient rocks, a silent testament to a day of violence beyond all human comprehension. And so, after centuries of speculation from afar, after millennia of poetry and prophecy aimed at that silent silver disk, we finally went to get the answers ourselves. The Apollo missions were more than a geopolitical triumph. They were a scientific pilgrimage. Humanity for the first time was leaving its cradle to collect fragments of its own past, to bring back tangible pieces of the mystery that had haunted our nights since the dawn of consciousness. In sealed, sterile boxes, carried across the black void by returning heroes, came the ground truth. 382 kilograms of rock and dust, gathered from 6 different landing sites, promised to settle the debate once and for all. They were expected to be the key that would unlock one of 3 doors: a moon born from the Earth's own body, a moon born as Earth's twin, or a moon captured from the depths of space. But the universe is rarely so simple. Back on Earth, in pristine laboratories shielded from terrestrial contamination, a generation of scientists began the meticulous, almost sacred work of interrogation. They subjected these lunar samples to every test imaginable, using tools and techniques that were themselves on the cutting edge of human knowledge. They were opening a time capsule 4.5 billion years old. The first results that trickled in were not just surprising, they were confounding. They did not unlock one of the 3 doors. Instead, the evidence seemed to slam all of them shut, leaving cosmology in a dark, unfamiliar corridor with no obvious exit. The first clue was a profound and unexpected absence. We had long known the moon has a much lower density than Earth. Our planet, with its massive churning heart of iron and nickel, is a dense, heavy world. The leading theories had neat explanations for the moon's comparative lightness. The co-accretion model, for instance, suggested the moon simply formed from less iron-rich material in the same orbital neighbourhood. The fission theory proposed that the moon was spun out from Earth's lighter crust and mantle, leaving the dense iron core behind. But the Apollo samples revealed a starker truth. The lunar rocks were fantastically poor in iron. The moon wasn't just a little lighter. It was fundamentally missing its metallic heart. Geochemists calculated that its core could be, at most, a tiny fraction of its total mass, perhaps only 2 or 3%. For a planetary body of its size, this was deeply strange. It was like finding a great beast with a minuscule skeleton. This one fact placed both the co-accretion and capture theories in grave jeopardy.
Moving at light speed.
If the moon had formed alongside Earth, it should have drawn from the same pool of materials and built a proportionally similar iron core. If it had been captured as a fully formed rogue planet, it would be a cosmic miracle for it to be so anomalously iron poor. It was a finding that didn't fit the established narratives, a deep structural anomaly that pointed to a formation process far more specific and perhaps far more violent than anyone had imagined. The second clue was just as baffling, and it centered not on what was present, but on what was missing. The moon. The rocks screamed in their silent chemical language,
Visualizing the
was
landscape
bone
of
dry,
quantum field theory.
extraordinarily, unnaturally, desiccated to an extent almost unheard of in the solar system. Scientists search for what they call volatiles, elements and compounds with
universe
low
is not a
boiling
static,
points, like
finished
water,
product,
sodium, potassium,
but a
and zinc.
dynamic,
These are
evolving.
the ingredients that easily turn to gas when heated. On Earth, they are everywhere. They are locked in our rocks, dissolved in our oceans, and cycling through our atmosphere. Any celestial body that formed through the slow, gentle aggregation of smaller planetesimals, the standard model for planetary formation, should be rich in these same volatiles. They are the cosmic mortar holding the planetary bricks together. The capture theory predicted a moon born elsewhere would have its own unique and likely abundant complement of volatiles. The co-accretion theory demanded a moon built from the same volatile-rich recipe as Earth. The Apollo samples told a different story. They were almost entirely devoid of water locked within their crystalline structures. Other volatile elements were so depleted it was as if some colossal fire had systematically baked them out, boiling them away into the vacuum of space. This was not a gentle formation. This was evidence of a traumatic high-energy event, a celestial blowtorch of unimaginable scale and intensity.
Deep beneath the border,
The moon
the
hadn't
large
just formed.
hadron core
It seemed
accelerates
to have been
protons
forged in
to
an
nearly
immense
the speed
crucible
of
that
light.
reached thousands of degrees, an oven hot enough to vaporize rock and drive off any trace of water or other easily lost elements. The gentle gravitational waltz of co-accretion or the elegant cosmic catch of capture could not account for this. The fission theory, with its vision of a rapidly spinning molten Earth, came closer to providing the necessary heat, but the physics required were becoming more and more untenable. The Earth would have had to spin impossibly fast, a day lasting perhaps only 2 hours, to throw off a body the size of the Moon. Such a dramatic spin would have left other signatures in the Earth-Moon system, signatures that we simply do not see. The clues were piling up and they were pointing away from every established theory. The lunar samples, which were meant to be a Rosetta Stone, were instead presenting a script written in an alien dialect, describing an event that no one had yet dared to conceive. But it was the third clue that delivered the fatal blow to all conventional wisdom. It was a discovery so precise, so unambiguous, that it remains the single most important and most restrictive piece of evidence we have for the Moon's origin. It lies hidden at the atomic level, in the very identity of the elements that make up our two worlds. This is the science of isotopes. Think of an element, like oxygen, as being defined by the number of protons in its atomic nucleus. All oxygen atoms have 8 protons. However, the number of neutrons can vary slightly. These different versions of the same element, with different numbers of neutrons, are called isotopes. Oxygen-16, with 8 protons and 8 neutrons, is the most common. But there is also oxygen-17 and oxygen-18, with 1 or 2 extra neutrons.
The laws of physics.
Crucially, the specific ratio of these different isotopes acts as a unique, unforgeable birth certificate for every object in the solar system. The primordial cloud of gas and dust from which our sun and planets formed was not perfectly mixed. Like a poorly stirred batch of cosmic dough, different regions had slightly different concentrations of various isotopes. As a result, every planetary body, Earth, Mars, Jupiter, and even the asteroids, condensed with its own distinct isotopic fingerprint. A rock from Mars has a Martian oxygen isotope ratio, completely different from a meteorite that originated in the asteroid belt, and both are completely different from a rock found on Earth. This isotopic signature is fundamental. It tells you, with near-perfect certainty, where in the solar system an object was born. This was the ultimate test for the lunar origin theories. If the Moon were a captured object, a wanderer from the outer solar system, its isotopic fingerprint would be wildly different from Earth's. The Apollo samples would have screamed alien. If it had formed via co-accretion, in a similar but distinct orbit, it should still have a slightly different signature. Even a close sibling has its own identity. It would be recognisably related to Earth, but definitively separate. The fission theory was the only one that predicted a perfect match, as the Moon would be made of pure Earth mantle material. The scientific community held its collective breath as the lunar rocks were vaporized in mass spectrometers, their atomic souls laid bare. The result was a bombshell. It was an impossibility that stared back from the data with unnerving clarity. The oxygen isotope ratios of the lunar samples were not just similar to Earth's. They were identical, indistinguishable. To the limits of our most sensitive instruments, the rocks collected by the Apollo astronauts had the exact same atomic signature as the rocks beneath our own feet. Earth and the Moon were not siblings. They were not cousins. From an isotopic perspective, they were twins. Perfect, identical twins. This single discovery rendered the capture theory utterly impossible. The odds of capturing a rogue planet from elsewhere in the solar system that just happened to have the exact same isotopic makeup as Earth were not just astronomical, they were nonsensical. It shattered the co-accretion model as well.
Might come from
Two separate bodies of this size to form independently from the
anomalies,
protoplanetary
digital
disk,
seams in
yet
our
end up with a
simulated
perfectly
reality.
blended, identical mixture of materials, defied all models of orbital dynamics and accretion. It left only the fission theory, but as we've seen, that idea was already buckling under the weight of its own impossible physics. The scientific community had arrived at a profound and deeply uncomfortable impasse. The data from the Moon, our greatest prize from the space race, had systematically destroyed every plausible explanation for its existence. The case was cold. The clues contradicted each other. The Moon was small of heart, baked dry, and yet, atomically, it was a ghost of the Earth itself. It was a paradox written in stone and starlight, and it demanded a new kind of answer. It demanded a culprit, an event that was not gentle or elegant, but catastrophic.
Consciousness.
Into this intellectual vacuum in 1975 stepped two planetary scientists, William Hartmann and Donald Davis. They were studying the early solar system, not as the orderly clockwork mechanism it appears to be today, but as the chaotic, violent shooting gallery it truly was. Their models were filled with planetesimals, hundreds of Moon-to-Mars-sized objects careening through the inner solar system on unstable orbits. Collisions were not an exception, they were the rule. It was a game of cosmic billiards where planets grew by devouring their smaller rivals. Looking at the strange collection of clues from the Apollo missions, they posed a question that was, at the time, staggeringly radical. What if the Moon wasn't born from Earth, or with Earth, or captured by Earth? What if the Moon was the result of a crime? A planetary hit-and-run of unimaginable proportions. Their proposal, published in the journal Icarus, now was called the Giant Impact Hypothesis. It was breathtaking in its audacity and its violence. The theory painted a picture of the very young Earth, perhaps only 30 or 50 million years after its formation, still a molten ball of magma. On a collision course with it was another young planet, a protoplanet that scientists would later name Theia, after the Greek Titan who was the mother of Selene, the goddess of the moon. Theia was not a glancing asteroid. It was a formidable world in its own right, roughly the size of Mars, and it wasn't aiming for a near miss. It was going to strike the Earth. The impact they described was an event that transcends all earthly scales of comparison. It was not an explosion, it was the remaking of a world. Theia, travelling at tens of thousands of kilometres per hour, slammed into the proto-Earth at an oblique angle. The energy released in that singular moment beggars belief. It would be equivalent to trillions of the largest nuclear weapons detonating simultaneously, an incomprehensible flash of creation and destruction that would have vaporized both the impactor and a huge portion of the Earth's own mantle. This was not a cratering event, it was a planetary fusion. In this single, violent hypothesis, the contradictory clues from Apollo suddenly began to fall into place. First, the missing iron core. In the computer models that Hartmann and Davis ran, the collision was so powerful that the dense iron core of the impactor Theia was not ejected. Instead, it plunged through Earth's already molten mantle and merged with our own planet's core. Earth became heavier, its heart enriched with the metal of another world. The debris blasted into orbit. The raw material for the future moon would therefore be composed almost entirely of the vaporized, iron-poor mantles of both Theia and Earth. This elegantly explained why the moon is so anemic, so lacking in the iron that should define a body of its size. Its share was stolen by Earth in the cataclysm of its birth. Second, the mystery of the missing volatiles. The giant impact wasn't just a collision, it was a thermodynamic event of the highest order. The energy of the impact would have created a magma disk of superheated rock and gas orbiting the Earth, with temperatures soaring to many thousands of degrees.
I honestly can't
In
remember
this
the last
cosmic
time we all did
furnace,
this.
any water, any sodium, any zinc,
Perfect, isn't it?
any volatile
We have
element
to do this more
would have been
often.
instantly vaporized and boiled away into space. Only the most refractory high-temperature materials, the silicates and oxides, would survive to condense and clump together. The moon, therefore, wasn't just born dry, it was born of fire, cleansed of any trace of water by the sheer ferocity of its creation. It perfectly explained the bone-dry nature of the Apollo rocks, and finally, the isotopic fingerprint, the most restrictive clue of all. This was, admittedly, the trickiest part for the early hypothesis. The initial model suggested that most of the material in the orbiting debris disk, and therefore most of the Moon, should have come from the impactor, from Theia. If Theia, like Mars or the asteroids, had formed in a different part of the solar system, it should have had a different isotopic signature. A moon made mostly of Theia should not be an isotopic twin of Earth. This was a genuine problem, a detail that the first simple version of the hypothesis couldn't fully resolve. Yet, crucially, it did allow for a significant portion of the Earth's own mantle to be blasted into the mix. Unlike any other theory, it provided a natural mechanism for mixing large quantities of material from two different bodies, one of which was the Earth itself. It wasn't a perfect explanation for the identical twin signature, not yet, but it came tantalizingly, intoxicatingly closer than any other idea. It suggested that the two worlds were so thoroughly and violently scrambled together that their atomic identities were irrevocably blended. The reaction from the broader scientific community was not one of immediate universal acceptance. It was, to be blunt, one of deep skepticism. The idea felt too convenient, too ad hoc. To many astronomers, steeped in the more stately uniformitarian principles of gradual change, it seemed like a fudge factor, a deus ex machina, invented to solve a problem that had no other solution. The prevailing view of planet formation was still one of relative order. Proposing that our own world was the product of such a singular, monstrously chaotic event felt unscientific, like replacing elegant celestial mechanics with a story of a random cosmic brawl. It was a theory born of catastrophe, and many were reluctant to believe that our planet's story had such a violent and arbitrary beginning. The debate was fierce. The giant impact hypothesis was a target, a wild new contender in an arena that had been occupied by the same three aging champions for nearly a century. It had to prove itself not just as a plausible story, but as a physically viable mechanism. The blueprint was there, sketched out in a moment of brilliant insight that connected the disparate, confusing clues lying in vacuum-sealed boxes from the moon. But could this incredible story be proven? Could we resurrect this ghost from the past, not just in theory, but in the digital crucible of a supercomputer, and watch a world be destroyed and a moon be born? The key, it turned out, was not buried in more lunar rock, nor was it waiting to be found in the spectral light of a distant star. For decades, the origin of the moon had become an intractable problem, a collection of beautiful but fatally flawed theories, each one dashed against the stark, unyielding facts returned by the Apollo missions. The paradoxes they presented, a world born of fire yet poor in iron, a body spun off from Earth yet strangely dry, a twin in chemistry yet a stranger in composition, had created a scientific impasse. The field was frozen in a state of brilliant uncertainty. To move forward, science would need a new kind of tool, not a shovel or a telescope, but a time machine. A machine built not of gears and steel, but of logic and light. A machine that could travel back 4.5 billion years to witness an event no one could have possibly seen. The age of the supercomputer had arrived, and with it the power to resurrect a ghost. In the 1980s and 90s, a revolution was quietly unfolding in laboratories and universities around the world. Computational power, once the exclusive domain of governments and vast corporations, was beginning to accelerate at a breathtaking pace. For a new generation of planetary scientists, these machines offered something tantalizingly close to omniscience. They could construct virtual solar systems inside a box, programming the fundamental laws of the universe, gravity, thermodynamics, momentum, and then letting them run. It was a digital petri dish for creation, a place where they could test ideas too vast, too violent, or too ancient for any physical experiment. They could hurl planets at one another again and again, tweaking the variables with each attempt, all in the quest to solve the lunar conundrum. The giant impact hypothesis, a radical and audacious idea that had been lingering at the fringes of astronomy since the 1970s, was about to be put on trial. This was not merely about plugging in numbers. It was an act of profound imagination, requiring scientists to think like cosmic architects. They had to define the proto-Earth, not as the tranquil blue marble we know, but as a nascent molten sphere still glowing with the heat of its formation. They had to specify its mass, its spin, its chemical makeup. Then came the phantom assailant, the hypothetical planet Theia. What was its nature? How large was it? Was it the size of Mercury or Mars or something even greater? From what direction did it strike? Was it a calamitous head-on collision, an apocalyptic shattering of both worlds? Or was it something more oblique, a cosmic sideswipe? And at what velocity did this doomed titan approach? Each of these parameters was a dial to be turned, a variable in a celestial equation of unimaginable complexity. The early simulations were crude by modern standards, representing worlds as a few thousand particles or points of mass, each one pulling on every other. Yet even in these ghostly low-resolution ballets, something extraordinary began to happen. The hypothesis began to breathe. Imagine you're sitting in a darkened room, the only light coming from a monitor displaying a dance of digital dust. You're watching the work of pioneers like Alistair Cameron and William Ward, or later, the intensely focused efforts of researchers like Robin Carnap. On the screen, two spheres of light, one large and one small, are set on a collision course. The smaller sphere, our digital Theia, doesn't plunge directly into the proto-Earth. Instead, in the most successful models, it delivers a massive grazing blow. The moment of contact is not an explosion in the traditional sense. It is a fluid, terrifying merger of worlds. For a few brief silent moments on the screen, the two planets deform, their molten surfaces rippling like liquid under the inconceivable strain. Theia's momentum is so immense that it carves a canyon of fire through Earth's mantle, its own body being torn apart, stretched, and vaporized by the sheer tidal forces and unimaginable energies being released. You're witnessing the single most violent event in our planet's entire history, played out in the sterile, silent confines of a computer. What happens next is the heart of the revelation. The impact acts like a cosmic slingshot. A vast plume of material, a mix of Theia's shattered mantle, and a significant portion of the proto-Earth's own outer layers is ejected into orbit. This is not a spray of solid rocks. It is a superheated cloud of vaporized silicate and molten droplets, glowing brighter than a star. The simulation shows this incandescent debris cloud expanding rapidly, forming a vast ephemeral ring around the wounded, rapidly spinning Earth. And here, the first of the Apollo paradoxes begins to melt away. The iron. Theia's dense iron core, heavier and less easily deflected, is not part of this vaporous plume. In the simulation's elegant choreography, the gravitational drag is too great. The core of the impactor plunges onward, burrowing deep into the proto-Earth and merging with our own planet's core within hours. The material thrown into orbit is therefore naturally, catastrophically, depleted of iron. The computer had just built a world poor in iron, exactly as the lunar samples demanded. It was a breathtaking moment of convergence, where abstract theory and physical evidence finally shook hands. But the simulation story was far from over. Within this swirling, chaotic disk of debris, gravity begins its patient, inexorable work. The countless particles, each with its own trajectory, start to interact. Clumps begin to form, sweeping up smaller particles in their path. Over a timescale that is shockingly brief, perhaps only a few years, a century at most, a single, dominant body emerges from the
The
maelstrom.
relentless human.
This body,
need
the
to
nascent
know.
moon, grows rapidly, feeding on the remnants of the debris ring. The simulation had not only explained the
At the
moon's lack of a
subatomic
large iron
scale,
core,
all
but
bets
it had
are
also
off.
demonstrated a viable mechanism for its formation in
quantum
an
realm.
astonishingly short period of cosmic time. It wasn't born slowly over millions of years. It was born in a flash of violence, a phoenix rising from the ashes of a planetary collision. Now the scientists could turn their attention to the other mysteries locked in the Apollo rocks. The magma ocean, the evidence that the moon was once entirely molten, had always been a puzzle. What could possibly generate that much heat? The simulation provided a visceral answer. The energy released in the giant impact was almost beyond human comprehension, equivalent to trillions of nuclear bombs. The material ejected into orbit wasn't just warm, it was plasma, a superheated gas of dissociated atoms. As this material coalesced to form the moon, that primordial cataclysmic heat was locked within it. The newborn moon was not a solid body with a molten surface. It was a sphere of liquid rock, a glowing drop of magma hanging in the sky. The computer model didn't just permit a magma ocean, it demanded it. Another piece of the puzzle clicked decisively into place. And then there was the most subtle, yet most profound of the chemical clues, the identical isotopic fingerprints. If the moon was mostly made of Theia, why did it look, isotopically, exactly like the Earth? This had been the Achilles heel for many early impact models, but the new, more sophisticated simulations, particularly those that followed in the late 90s and early 2000s, revealed the sheer violence of the mixing. The impact didn't just chip off a piece of Earth's mantle, it created a temporary shared atmosphere of vaporized rock that enveloped both the Earth and the debris disk. Within this searing, turbulent envelope, the atoms of Earth and the atoms of Theia were blended together with incredible efficiency, like cream stirred into coffee. The distinction between terrestrial material and Theia material was erased in a crucible of unimaginable temperature and pressure. When the moon finally condensed from this homogenized vapor, it was born with Earth's chemical signature ingrained in its very essence. It was Theia's child, but it carried Earth's DNA.
No solid ground.
Robin Canup, working with a new level of computational fidelity, became a master of this virtual creation. She could run not one, but hundreds, even thousands of simulations, systematically altering the initial conditions. Her work transformed the hypothesis from a compelling sketch into a high-resolution portrait of our past. By adjusting Theia's mass, its impact angle and its velocity, she could explore the full range of possible outcomes. Too small an impactor, and not enough material would be ejected to form a stable moon. Too large or too direct, and the proto-Earth might have been completely destroyed. Too fast, and the debris would escape Earth's gravity entirely, scattering into the solar system. Her meticulous research narrowed the possibilities, painting a picture of a very specific kind of event. The most likely scenario, the one that best matched all the physical evidence we have today, was a Mars-sized impactor striking a glancing blow on a young Earth, just energetic enough to create the moon and set our world on its present course. Her models even correctly predicted the final piece of the dynamical puzzle, the angular momentum. The Earth-Moon system spins faster than it should for its size, a lingering sign of the rotational energy imparted by that ancient off-center collision. The simulation showed that a grazing impact was the perfect mechanism to spin the Earth up like a top and kick the newly forming moon into a wide, stable
We're exceeding
orbit.
the limits. Cut
It was
the
a
power
gravitational
now.
gyroscope set
not
in motion
responding.
by a ghost planet 4.5 billion years
My
ago,
God, it's opening.
and the computer model had finally allowed us to see how it was wound. The effect on the scientific community was seismic. The giant impact hypothesis was no longer just a plausible story. It was a mathematically robust and visually compelling explanation that solved, in one elegant and violent stroke, nearly all of the lunar paradoxes that had plagued science for generations. It explained the lack of iron. It explained the magma ocean. It explained the chemical kinship. It explained the system's angular momentum. The digital recreation of this ancient cataclysm had provided a kind of evidence that was previously unimaginable. It was a witness. A ghost from the past, summoned in a machine, had testified to the brutal and spectacular birth of our world and its constant companion. The debate wasn't over, but the ground had irrevocably shifted. The question was no longer if a giant impact had happened, but the precise details of how. We had resurrected Theia in
The search
virtual
for the
world,
Higgs boson,
watching it perform
the
its one and
central,
only act on the
driving
cosmic
obsession
stage.
of particle physics for a generation.
We'd seen its form, calculated its mass, and charted its final fatal trajectory. Yet this very success opened up a new, more profound set of questions. This ghost now had a name and a history, but its origins remained shrouded in the deepest mists of solar system formation. Where did this Mars-sized world come from? Was it a sibling planet,
is yours.
formed in the same neighbourhood as Earth, its orbit slowly destabilising over millions of years? Or was it a wandering orphan from the outer solar system, drawn inward by the immense gravity of Jupiter and set on an inexorable path of destruction? The computer had shown us the moment of Theia's death. Now, we had to begin the search for its life. We had to hunt for its birthplace. For a time, the cosmic crime scene appeared solved, the grand narrative of the giant impact hypothesis felt complete, a breathtakingly elegant solution that seemed to account for every piece of the puzzle. It explained the moon's barrenness, its small iron core, the strange tilt of our planet, and the furious accelerated spin of the early Earth-Moon system. The computer models, running for weeks on end, painted a vivid and convincing portrait of a cataclysm that forged our world anew. It was a triumph of human intellect, a story we told ourselves with growing confidence, a case we believed was finally closed. But science is a restless detective, one that never truly rests. It constantly develops new tools, new techniques for interrogation, allowing it to ask the same witnesses, the rocks, the light, the very elements themselves, questions of ever finer detail. And deep within the pristine vaults of our laboratories, a ghost was stirring. A chemical spectre hidden in plain sight within the Apollo samples for decades was about to emerge from the data. A phantom that would challenge the very foundation of our beautiful theory and plunge lunar science into a crisis of identity. To understand this crisis, we must look deeper than rock and dust, deeper even than minerals. We have to journey into the heart of the atom itself. Every object in our solar system, from the mightiest gas giant to the smallest grain of interstellar dust, carries a chemical passport. This is its isotopic signature. Think of an element, like oxygen, the third most abundant in the cosmos. In its most common form, an oxygen atom has 8 protons and 8 neutrons in its nucleus.
If everything is
This
temporary,
is oxygen-16.
if everything could
But
collapse,
nature allows for slight
then the
variations.
most meaningful
An atom
thing-
of oxygen can also exist with 9 neutrons, making it oxygen-17, or even 10, creating oxygen-18. These variants are called isotopes. They are all chemically oxygen. They will still bind with hydrogen to make water, but they have subtly different weights. For scientists, these tiny differences in mass are everything. The precise ratio of these oxygen isotopes is forged in the swirling chaos of the protoplanetary disk, the vast nursery of gas and dust from which the sun and planets were born. Local conditions, temperature, pressure, proximity to the young sun, created unique isotopic recipes for different regions of this disk. A planet that forms in one neighbourhood will have a measurably different isotopic fingerprint from a planet that forms millions of miles away. It is an unforgeable, primordial birth certificate, a line of cosmic ancestry written into every single rock. We see this written across the solar system. Martian meteorites that have crashed on Earth carry a distinct Martian oxygen signature, completely different from our own. Asteroids from the Vesta family have their own unique ratio. Each one tells us where it came from, a chemical postcard from its home. This is where the giant impact hypothesis was about to face its greatest test. The theory was beautifully simple in its prediction. If a Mars-sized planet named Theia, born in a different part of the solar system, slammed into the proto-Earth, then the Moon, which our model showed was formed mostly from Theia's debris, should carry Theia's isotopic passport. The Moon should be a chemical alien. It should look, at an atomic level, profoundly different from the Earth. For decades after the Apollo missions, our instruments were simply not precise enough to make this definitive measurement. The signatures of Earth and the Moon looked similar, yes, but there was enough uncertainty, enough wiggle room in the data to allow for a foreign entity like Theia to be the dominant
Probing
parent.
the fabric of
The
reality
theory held,
unravels
but as
not
we
just
crossed into the
physics'
21st
equations.
century, a new generation of
Story.
technology came online. Inside laboratories shielded from cosmic rays and seismic vibrations, scientists began employing new techniques, centered around instruments of almost unbelievable sensitivity. Multi-collector inductively coupled plasma mass spectrometers. It's a mouthful, but what they do is pure magic. They are atomic sorting machines. A microscopic sample of lunar rock, painstakingly acquired by astronauts a generation earlier, is vaporized into a plasma hotter than the surface of the sun. This superheated cloud of individual atoms is then fired as a beam through a series of powerful magnets. Just as a strong crosswind affects a marble more than a cannonball, the magnetic field deflects the path of each atom according to its exact weight. The heavier isotopes, like oxygen-18, are nudged less than their lighter cousins. At the end of this atomic racetrack, a series of sensitive detectors, the multi-collectors, count each individual atom with extraordinary precision. We were no longer just looking at the isotopic signature, we were sequencing its every letter down to a few parts per million. For the first time, we could truly compare the Earth's passport with the Moon's. The expectation was clear. Somewhere in that fantastically precise data, we would finally see it. We would find the chemical ghost of Theia. The first results began to trickle in, focusing on those crucial oxygen isotopes, and they were stunning. The teams ran the tests again. They recalibrated their multi-million-dollar machines. They checked for contamination, for experimental error, for any possible flaw in their methods, because the data simply could not be right. The numbers that stared back from their screens were not just similar, they were, within the vanishingly small margin of error, identical. The Earth and the Moon were not just related, they were isotopic twins. It was as if you had conducted a DNA test on a supposed half-sibling,
Our subjective
expecting to find a
feeling of
50%
time flow
match, only to discover a
an illusion.
100% genetic clone. It made no sense. This wasn't a small discrepancy. It was a direct, violent contradiction of the standard model of the giant impact. The simulations, so powerful in their predictions of planetary dynamics, were unequivocal. The vast majority of the material that ended up in the lunar-forming disk, somewhere between 70 and 90%, should have come from the mantle of the impactor, Theia. The Earth itself, while horrifically wounded, should have contributed relatively little to the final mass of the Moon. Therefore, the Moon should be
Building
overwhelmingly
machines to
Theian
see
in
the
its chemical
invisible,
composition.
touch the
And
intangible,
yet, here was the evidence,
measure the
etched into the
immeasurable.
atoms themselves, screaming that the Moon was overwhelmingly Earth. The crisis rippled through the planetary science community. What had been a celebrated theory was now facing a potential falsification, the most dreaded word in science. The problem only deepened as researchers turned their incredible new instruments to other elements. They analysed silicon. Again, a perfect match. They measured the isotopes of titanium, a resilient element forged in the heart of dying stars. Identical. They looked at potassium, tungsten, chromium, a whole suite of elements that should have carried Theia's alien signature. In every single case, the result was the same. The Earth and Moon were cut from the very same atomic cloth. This isotopic crisis forced a painful and humbling realization. Our story of the Moon's birth, as elegant as it was wrong. Or at the very least, it was dangerously incomplete. The simple, clean image of a glancing blow from a foreign body could no longer explain this profound, almost mystical chemical connection. It was like finding that two cars involved in a head-on collision were now, impossibly, made of the exact same batch of metal, down to the last molecule. Something was missing from the story. A crucial chapter, filled with unimaginable violence and physics we had not yet dared to model, had to be written. Scientists faced with this paradox did what they do best. They went back to the drawing board, armed with this confounding new clue. How could you get a moon made of earthly material from a collision with a foreign object? The first, and perhaps simplest explanation was to question one of the core assumptions. What if Theia wasn't a stranger? What if, by some astronomical fluke, Theia was Earth's long-lost twin? Perhaps it had formed in the exact same orbital neighbourhood, coalescing from the very same plume of gas and dust as the proto-Earth. In this scenario, Theia would have had the same isotopic signature as Earth from the very beginning. The collision would have simply mixed identical materials, resulting in a moon and an Earth that were naturally isotopically indistinguishable. It's a tidy solution, almost too tidy. The problem is one of probability. The early solar system was not a tranquil place. It was a chaotic shooting gallery of planetesimals, with gravitational nudges from giants like Jupiter constantly stirring the pot. The idea that two massive Mars-sized bodies could form and remain in such a close, stable orbit, likely at a gravitationally balanced Lagrange point, without their building blocks being mixed with materials from other parts of the solar system, stretches the bounds of credulity. It would be an astonishing coincidence, a cosmic roll of the dice that came up double sevens. While not strictly impossible, relying on such a special, fine-tuned circumstance
multiversal
left
domino
many
effect.
scientists deeply
They're
unsatisfied.
all connected.
Science prefers explanations that are robust, not those that hinge on a lucky accident. A second, more complex idea began to gain traction. one that embraced the physics of the impact itself. Perhaps the initial materials were different. Perhaps Theia was indeed an alien world, with its own distinct chemical passport. But what if the collision was so energetic that it didn't just melt rock, but vaporized it on a planetary scale? This line of thinking proposed a radical new stage in the aftermath of the impact. In this model, the Earth and the newly formed debris disk were so superheated that they were enveloped in a shared, unified atmosphere made not of gas, but of silicate vapor, a fog of molten rock. This incandescent shroud, thousands of degrees hot, would have connected the surface of the mangled Earth to the cloud of debris from which the Moon would soon coalesce. For a period of perhaps hundreds or thousands of years, this common atmosphere would have acted as a colossal chemical blender. Turbulent, convective currents within this rock vapor would have ferociously mixed material from the Earth's mantle with the vaporized remnants of Theia in the disk. Atoms would be exchanged back and forth, a constant violent dialogue between planet and disk, until the entire system reached a state of chemical equilibrium. In this scenario, the Moon doesn't form from Theia's material. It forms from a thoroughly homogenized soup of Earth and Theia material, a soup whose final isotopic signature would be dominated by the much larger Earth. This post-impact equilibration model was clever and compelling. It preserved the powerful dynamics of the giant impact while offering a physical mechanism to explain the isotopic twinship. It painted an even more hellish dramatic picture of Earth's early days, a glowing, vapor-wreathed world, its surface indistinct from the seething disk that surrounded it. Yet this model too faced significant hurdles. For this great chemical mixing to happen so completely, the silicate atmosphere had to persist for a long time and be incredibly turbulent. But the disk of debris would have been cooling rapidly as it radiated heat into the cold vacuum of space. Was there truly enough time for every last pocket of Theian material to be thoroughly blended with Earth's before the Moon began to form? The physics of large-scale turbulent diffusion in a gravitationally bound vapor disk are fiendishly complex, and even today, models struggle to confirm if such a perfect homogenization is truly possible within the required time frame. It was a brilliant and plausible idea, but it remained a difficult one to prove. The search for a more definitive answer continued, pushing theorists to consider even more extreme possibilities. This pressure forced a fundamental re-evaluation of the impact itself. Our classic models, the ones that had served us so well, depicted a glancing blow. A massive hit, to be sure, but one where the proto-Earth remained largely intact, and Theia was mostly destroyed. But what if that wasn't violent enough? The isotopic crisis was acting like a new, immovable constraint, a demand from nature that our theory must satisfy, and it seemed to be demanding a far greater degree of mixing, a more profound scrambling of the two worlds than we had ever imagined. This led some to wonder. What if the impact was not a glancing blow, but something much more direct? What if the impactor was moving much faster? What if the collision was so catastrophically energetic that it didn't just vaporize the outer layers of both planets, but obliterated them entirely? A new class of models began to emerge, scenarios that depicted an event of almost unimaginable ferocity. These weren't just impacts anymore, they were acts of planetary annihilation and rebirth. In these scenarios, the proto-Earth and Theia are both completely destroyed. They are transformed into a single, massive, rapidly rotating and undifferentiated cloud of molten rock and vapor, a bizarre and unprecedented astronomical object called a synestia. This was the new frontier. The isotopic crisis had acted as a powerful catalyst, killing the simple, elegant theory of a straightforward collision and forcing science to imagine a genesis story of almost transcendent violence. It revealed that the Apollo samples, those silent grey rocks, held a secret far stranger than we could have guessed. They told us that the bond between Earth and Moon was deeper, more fundamental, more like that of identical twins than of a parent and a stepchild. The question was no longer simply, how did the Moon form? The question had become, what kind of cosmic crucible is powerful enough to take two distinct worlds, with their own histories and their own chemistry, and smelt them together so perfectly that their individual identities are utterly erased, reforged into a single unified chemical being? Finding the answer would require pushing our computer simulations and our imaginations into a realm of planetary physics so extreme it borders on the sublime. The ghost in the machine had spoken, and it demanded a new story. A story of fire and fury far beyond our previous telling. And so, we were left with this ghost, this impossible spectral fingerprint. The rocks returned from the moon by the Apollo astronauts, silent witnesses to a forgotten age, had presented us with a paradox that threatened to shatter our most elegant creation story. They whispered a truth that science could not, at first, comprehend. Earth and Moon were twins, identical down to the last atom of their shared oxygen, their shared titanium, their shared elemental soul. The giant impact hypothesis, a vision of cosmic violence and creation so powerful it had captured the imagination of a generation, was now haunted by this single, damning fact. If the Moon was born from the body of a wandering planet named Theia, it should carry Theia's distinct chemical signature, its own unique isotopic dialect. Yet, it did not. It spoke with Earth's voice, a perfect echo of our own planetary DNA. Planetary science had been painted into a corner, trapped between a theory that explained so much about the mechanics of the Earth-Moon system and the stark, contradictory evidence held in our hands.
Its sustained
The beautiful,
energy
simple
output is a
story of a
direct
glancing blow was
consequence of
dying,
quantum tunneling.
and for a time, there was nothing to take its place. We had followed the trail of evidence to the scene of the greatest crime in our planet's history, only to find the culprit had left behind our own fingerprints. How do you solve a mystery like that? Where do you turn when your best theory, the product of decades of brilliant work, is contradicted by the very ground truth you sought to explain? You do not abandon the scene. You look closer. You question not the event itself, but your own assumptions about its nature. The problem, a new generation of scientists began to argue, was not with the idea of an impact. The sheer scale of the Moon, its peculiar orbit, the Earth's rapid spin, all these things still pointed to a cataclysm of unimaginable proportions. No, the problem was with our imagination. Our models had been too timid, too constrained by the neat, orderly physics of solid bodies colliding in the sterile vacuum of a supercomputer. We had envisioned a cosmic billiard shot, a simple, almost elegant exchange of mass and momentum. But what if it wasn't a collision? What if it was a metamorphosis? What if the impact was so violent, so utterly transformative, that the very concepts of Earth and Theia ceased to have meaning in its immediate aftermath? To test this, we needed more than elegant equations. We needed raw power. We needed to build virtual universes inside machines, to unleash digital titans upon one another and watch, frame by agonizing frame, as new worlds were forged in simulated fire. The supercomputers of the 21st century, capable of trillions of calculations per second, gave us a new kind of telescope. Not one pointed at the stars, but one pointed back into the deepest moments of time. They allowed us to explore scenarios previously unthinkable, to crank up the energy, the velocity, the sheer ferocity of this ancient encounter. And from this digital crucible, new, more radical ideas began to emerge, each one attempting to solve the riddle of the identical twins. One of the first and most intriguing was the hit-and-run scenario. Imagine Theia not as a world ender, but as a cosmic marauder, a gravitational thief moving at incredible speed.
Rerouting the grid for a
In this
focused
revised
scan
script,
now.
Theia doesn't merge with the proto-Earth in a final fatal embrace. Instead, it strikes a devastating, high-velocity glancing blow, a powerful but fleeting encarnor. The energy of this
Rethinking how we
impact would have
treat
been
each other.
immense, far
Our
greater than
fragile
in the classic
planetary
model.
home.
Theia would have acted like a celestial plough, carving a deep furrow into our planet's molten mantle, shearing away trillions of tons of terrestrial rock and flinging it into orbit. This colossal plume of debris, almost entirely composed of Earth's own material, would then become the raw ingredient for the Moon. Theia itself, though wounded and gravitationally altered, would have survived the collision, its trajectory bent by Earth's gravity as it continued its journey through the chaotic early solar system. This model was tantalizing. It neatly explained the isotopic similarity by ensuring the lunar building blocks were sourced directly from our own planet's mantle. The moon would be Earth's twin because it was, quite literally, born from Earth's flesh. But this solution, like a ghost, left its own lingering questions. A hit-and-run collision of this magnitude would have sent Earth spinning at a ferocious rate, creating a day perhaps as short as 2 hours long. While we know the Earth's rotation has slowed over billions of years due to the moon's tidal influence, the physics required to break a planet from such an extreme initial spin are incredibly difficult to reconcile. And of course, there is the most obvious question of all. Where is Theia now? Where is the body of this cosmic fugitive? Did it plunge into the sun? Was it ejected from the solar system entirely, now a rogue planet wandering the interstellar dark? Or could it, in a final twist of irony, be one of the other planets we see today, its identity forever masked by its ancient wounds? The hit and run was a brilliant piece of celestial detective work, but the case remained open. Another, equally compelling idea took a completely different approach. It questioned the very first word of the hypothesis, the giant impact. What if it wasn't a single, monolithic event at all? What if the moon wasn't born in one dramatic moment, but was instead assembled over millennia, piece by agonizing piece? This is the multiple impact hypothesis. It paints a picture of a young Earth under relentless siege. In this telling, there is no single Theia, no one fateful day. Instead, there is a prolonged era of bombardment, a hailstorm of large planetesimals, perhaps 20 or more, each slamming into the proto-Earth over millions of years. Each collision would have been a cataclysm in its own right, blasting a shower of molten debris into orbit. Individually, none of these impacts were powerful enough to form the moon we see today, but collectively they created a vast, sprawling disk of vaporized and molten rock around our world. Within this chaotic, swirling ring, gravity began its patient work. Small moonlets, or moonikins, would condense from the debris of each successive impact. These tiny moons would then collide and merge with each other, slowly building up into a larger and larger body. The beauty of this model is its statistical power. The debris from 20 different impactors, all mixed with a much larger volume of Earth's mantle material, would effectively average out. The unique isotopic signatures of the various impactors would be diluted into insignificance, washed away in a sea of terrestrial matter. The final moon, a composite of countless collisions, would naturally inherit the isotopic fingerprint of the largest and most consistently sampled object in the mix, our own Earth. It solves the isotopic crisis through sheer brute force and repetition, replacing a single dramatic narrative with a long, violent saga of planetary construction. Yet this too faces challenges. Getting the orbital mechanics of all these tiny moonlets to coalesce into a single, stable moon at the right distance and with the right tilt is a formidable ballet of gravity, one that our models are still struggling to perfect. Both of these ideas, the hit and run and the multi-impact saga, were profound leaps of imagination, pushing the boundaries of what we thought possible. They showed that scientists were willing to tear down their most cherished theories in the relentless pursuit of truth. But the ultimate answer, the one that seems to resolve the crisis most completely, would require a leap into an entirely new state of matter, a vision of creation so strange and so violent it forces us to redefine what it even means to be a planet. To find it, we must travel back to that moment of impact, but this time, we must turn the energy dial up past all previous limits. We must imagine an impact so powerful it doesn't just melt rock, it vaporizes it, it boils an entire world. This journey takes us to the work of planetary scientist Sarah Stewart and physicist Simon Locke. They looked at the isotopic crisis and saw not a contradiction, but a clue that told them the aftermath of the collision was a place of incomprehensible energy, a place where the materials of Earth and Theia were not just mixed, but utterly and completely unified. Their models unveiled a new theoretical celestial object, a transient state of being for a world pushed beyond its breaking point. They called it a synestia. The word itself is a fusion of syn, meaning together, and Hestia, the Greek goddess of the hearth and home, together in one body. A synestia is what you get when a collision between two planet-sized objects is so energetic and carries so much angular momentum that the resulting body can no longer exist as a simple sphere. Imagine the scene. A Mars-sized Theia, perhaps moving faster than in our classic models, slams into the young Earth. The energy released is not in the trillions of joules, but in the sextillions. It is an explosion that beggars belief, a celestial blowtorch that instantly vaporizes vast portions of both the impactor and our own planet's mantle. We are no longer dealing with liquid rock. We are dealing with rock gas. A colossal cloud of incandescent silicate vapor, expanding outwards at hypersonic speeds. But crucially, this impact also injects a tremendous amount of spin into the combined mass. The object tries to pull itself together under its own gravity, but it's rotating too fast. So fast, in fact, that its equator spins at orbital velocity. The very surface of this new object is moving fast enough to be in orbit around its own centre. The result is not a planet. It is something new. A vast, bloated, rapidly spinning donut of vaporized rock, 1,000 times the size of the modern Earth, glowing with the fury of a star. This is a synestia. It has no surface in the way we understand it. There is no clear boundary between atmosphere and planet. It is a single, continuous, seething entity of gas and liquid, a celestial furnace where pressures are immense
For decades,
and temperatures reach
physicists have harbored
thousands
a
of
deep
degrees
and
Celsius.
troubling suspicion.
And
that
inside
our
this
vacuum-
swirling, incandescent phantom of a world, the isotopic crisis vanishes. It simply ceases to exist. Think of it like adding a drop of red dye to a bucket of water. In the classic impact, the dye, Theia, splashes into the water, Earth, and for a while you can still see swirls of distinct colour. The debris that forms the moon is like scooping out a sample before it is
The
fully
mathematics
mixed.
that describes
But in the
the
Synestia
possibility
model,
of vacuum
the
decay
impact
does
is like
not,
putting that
on
dye
its
and
own,
water into an
provide a
industrial-grade
natural
blender
reason.
and turning it on full blast for 1,000 years. Within this turbulent, vaporized donut, the atoms of Theia and the atoms of Earth are indistinguishable. They are violently and perfectly homogenized, stirred together in a cosmic tempest on a scale we can barely comprehend. There is
A
no longer Theia
0.01%
material
chance.
or Earth material.
The model predicted
There is only
failure,
Synestia
but the
material,
outcome is
a
definitively
new,
positive.
uniform substance, forged from the union of two worlds. And it is from this substance that both Earth and Moon will ultimately be reborn. For a synestia is a fleeting thing, a temporary ghost in the cosmic machine. As this colossal spinning cloud radiates its ferocious heat into space, it begins to cool. And as it cools, something extraordinary happens. Deep within the hot, dense vapor, tiny droplets of liquid rock, like raindrops in a terrestrial storm cloud, begin to condense. Gravity gathers these droplets together. Close to the swirling center of the synestia, the seed of a new world begins to form.
We have
This
built
seed is
great
the moon.
systems of thought.
It does not accrete from a
religions,
distant cold disk of
philosophies,
debris over millions of
sciences.
years. It precipitates directly out of the hot atmosphere of the synestia, just a few thousand miles above the object's core. It is born in the heart of the furnace.
The pursuit itself
Because it
is
condenses
deeply
from that
meaningful,
perfectly mixed, homogenized
even if we can
vapor,
never prevent
its
it.
isotopic composition is, by definition, identical to that of the material that will eventually form the new Earth. They are drawing from the very same well. They are quite literally made of the same stuff, at the same time, in the same place. They are not just twins, they are conjoined,
This wave
born from the
represents
body of a
particle.
single,
It's
shared
a localized,
parent.
temporary disturbance.
Over the next few thousand years, a cosmic ballet unfolds. The Moon, now a substantial body, continues to orbit within the cooling, contracting synestia, sweeping up more material. Meanwhile, the synestia itself continues to shrink as it loses heat, its vast, vaporous structure collapsing downwards. Eventually it cools enough to shrink back within the orbit of the newly formed Moon, its incandescent gas condensing back into a liquid magma ocean. The synestia is gone, and in its place, spinning in the dark, are two new worlds. A larger Earth, its composition now a mix of its former self and the heavy core of Theia, which sank to its centre. And orbiting it, a smaller moon, a perfect isotopic reflection, a child born of fire and vapour.
But we can
The
choose
synestia
to live
hypothesis
with
is a
greater
breathtaking
intention.
piece of scientific thinking. It is elegant, it is violent, and it appears to solve
In an
the most
absurd,
profound mystery that the
meaningless
Apollo samples
universe,
revealed. It explains how
create
two
your
different
own
worlds can
meaning.
collide, yet give birth to identical twins. The price of this solution is the sheer, unbridled violence of the event it describes. It forces us to accept that our planet and its companion were not merely damaged and reformed by this impact. They were annihilated, completely unmade, atomized, and then utterly recreated from a shared incandescent cloud. This wasn't just the birth of the moon. It was the day the Earth was born for a second time, resurrected from its own fiery ghost. We are standing on the cooled ashes of a synestia. The ground beneath your feet, the rock of the deepest canyons, the very elements that make up your body, were once a
are
glowing
not
gas,
strictly bound by
part
the
of a
limits
structure
of
larger
classical
than
energy.
Jupiter's orbit, spinning furiously in the primordial dark. We have found, it seems, a creation story that is equal to the evidence, a story of destruction so complete it becomes an act of ultimate
Quantum
creation.
theory did not come without
In solving
deep
one mystery,
and often
we open the
bitter
door to another.
philosophical
If
debate.
this is how our world was forged, in a crucible of such unimaginable heat and fury, how did it ever become the haven we know today? How did this sterilized, vaporized sphere, born from the ghost of a planet, ever give rise to oceans, to an atmosphere, and ultimately to us? The birth of the moon, we are now realizing, was not the final chapter of our planet's violent youth. It was just the beginning. It set the stage, tilted our world on its axis, and perhaps, in the crucible of its formation, delivered the very ingredients that would one day allow life to begin its own improbable journey. And so, we find ourselves at the end of one story, and the beginning of countless others. We have journeyed back across 4.5 billion years through the silent darkness of the early solar system to witness an act of creation so violent it borders on the unimaginable. We have watched as computational ghosts born in supercomputers reenacted this cosmic collision, twisting and reforming our perception of that ancient past.
Y así,
From a
las
simple,
palabras fluyen,
elegant idea of a glancing
creando
blow,
realidades
our understanding
paralelas
has been
en la
shattered and
página en
rebuilt
blanco.
time and again into something far more complex, more chaotic, and profoundly more magnificent. The story of Theia is not merely the explanation for the silver disk in our night sky. It has become the story of our own improbable existence, a testament to the brutal creative power of the
Rotate the phase
universe.
diagram to 30 degrees.
The path to this understanding
Right
was
here.
never a
The
straight
green
line.
zone seems stable,
It has been a
but look at the
winding,
energy
difficult
spike near
road,
the singularity.
paved with centuries of human curiosity. For millennia, we gazed at the moon and saw a god, a goddess, a tranquil face, or a map of our own terrestrial fantasies. We saw it as a constant, a perfect and unchanging orb gliding through the heavens. Science, in its relentless pursuit of evidence, replaced that poetry with a different kind of awe. The first telescopes revealed a battered, cratered world, a landscape of ancient scars. Then, the Apollo missions, humanity's most audacious journey, allowed us to reach out and touch that world. The astronauts who walked on its surface were not just explorers, they were geologic time travelers, collecting the petrified echoes of a cataclysm. Those grey, unassuming rocks they brought back became the Rosetta Stones of our own origin story. Within their crystalline structures, we found the clues, the identical isotopic fingerprints that bound Earth and Moon together as cosmic twins. Yet this very evidence, this seemingly unbreakable link, became the central paradox of the giant impact. It was the beautiful, stubborn fact that broke our simple models. A glancing blow from a Mars-sized interloper, a distinct planetary body with its own unique chemistry, should have left a legacy of difference. Theia should have signed its name upon the moon, leaving behind an alien isotopic signature. But the signature wasn't there. The moon, it seemed, was almost entirely Earth. This is the very soul of scientific discovery. It is not a march toward infallible truth, but a dance with uncertainty, where every revelation illuminates a deeper, more profound mystery. The isotopic crisis forced a generation of scientists back to the drawing board, compelling them to imagine an impact of even greater ferocity. They had to envision a collision not of solid worlds, but a vaporizing, melting, all-consuming event. They had to conceive of something entirely new, a structure that was neither planet nor disk, but a swirling incandescent cloud of molten rock and vapor, the synestia. This ephemeral, superheated donut of planetary material was a concept born not from observation, but from the demands of the evidence itself. It provided a radical new crucible, a cosmic mixing bowl hot enough and vast enough to thoroughly blend the shattered remnants of both Proto-Earth and Theia, erasing the chemical distinctions between them. From this seething, glowing cloud, the moon could finally condense, a world born from a shared, vaporous womb. It is a vision of planetary birth that is almost terrifyingly elemental. It transforms the Earth and Moon from two separate objects into the surviving components of a single, unified system that was briefly torn asunder and then reborn.
Are you constantly planning for
We are
a
left to wonder
future
about the
that
ghost
may
in this
never
story,
come?
Theia. What was it truly like? Did it harbour the potential for its own oceans, its own atmosphere, its own destiny? Was it a dry, rocky world, or a water-rich planet whose stolen volatiles later rained down upon a cooling Earth, delivering the very oceans that would cradle life? We search for its faint echo, for some trace element, some isotopic whisper buried deep within the lunar mantle, or even our own, a final, definitive memento of the world that died so ours could thrive. This revised narrative, this story of total obliteration and rebirth, does more than just solve a local puzzle.
Each
It
breath
fundamentally
we take,
changes how we look
each
for
beat
life and
of our
habitability
heart
across the galaxy.
exists.
As we gaze out at the thousands of newly discovered exoplanets orbiting distant stars, we now understand that a planet's story isn't written in isolation. The space around it, the other worlds that share its orbit, are not just neighbours, they are potential architects of its fate. The existence of a large moon, once considered a mere curiosity, may in fact be a critical ingredient for complex life. Our moon
Live
is not a
fully,
passive companion.
courageously,
It is the gravitational
in
anchor that
each
stabilizes
and
our planet's
every
axial
moment.
tilt, preventing the wild, chaotic swings in climate that would have made the evolution of intelligent life exceptionally difficult, if not impossible. Imagine an Earth without its moon. Our planet's axis would wobble like a dying top, its poles shifting over thousands of years to where the equator once was. The climate would be a catastrophic pendulum, swinging from global deep freezes to scorching hothouses. Such instability is a formidable barrier to the long, slow, and relatively stable process of evolution required to produce something as complex as a thinking being. The moon,
Predictably
Theia's
downhill.
enduring legacy,
A ball
gifted
rolled.
us with climatic stability. It acts as our planet's gravitational gyroscope, keeping us steady on our journey through space and time. Furthermore, the moon is the engine of our tides. Its relentless pull on our oceans creates the intertidal zones, those dynamic, ever-changing ecosystems that may have been the very laboratories where life first experimented with crawling from the sea onto the land. This rhythmic gravitational heartbeat, a twice-daily pulse felt across the entire planet, has been a driving force of biological innovation for billions of years. So when we look for another Earth, another pale blue dot capable of hosting life, we must now ask a more complicated question. Where is its moon? How many worlds out there had the potential for life, but without a stabilizing partner, saw that potential extinguished by climatic chaos? The Theia impact, in all its random violence, may have been the winning lottery ticket for life on Earth. A fluke
We are
event
not
that
looking for
transformed our
particles or
world from just
waves.
another
We are
rock
looking
into a
for
cradle of
subtle,
consciousness.
telltale signs
The
that the
story,
rules governing
however, is
them are
far
beginning
from
to
over.
shift.
The script is still being written, and the next chapters will be penned not just in the memory of supercomputers, but on the dusty plains of the moon itself. We are standing at the dawn of a new age of lunar exploration. The Artemis missions are poised to take us back, not just to plant flags and take pictures, but to do the complex geological work that the Apollo astronauts could only dream of. We will send humans and robotic emissaries to places we have never been, armed with questions that were inconceivable 50 years ago. Our primary target is the Moon's South Pole Aitken Basin, the largest and oldest impact crater in the entire solar system. This colossal basin is a wound in the lunar crust, a chasm so deep it may have punched clean through to the Moon's upper mantle. It is a natural drill hole, offering us a tantalizing glimpse into the Moon's primordial interior. If any unmixed, unadulterated material from Theia's core or mantle survived the
Every
cataclysm,
laugh, every
this is
hug,
where we're most
every
likely to
sunset,
find it.
every human
A
experience.
sample
More
returned from the
vibrant,
depths of
real,
this basin
intense.
could be the smoking gun, the final, unambiguous piece of evidence that confirms the identity of the lost planet. By analysing the unique geochemistry of these ancient, deep-seated rocks, we might finally isolate the alien signature of Theia, distinguishing its original chemistry from the thoroughly mixed material that makes up most of the moon we know. Beyond the search for Theia, these new missions will also hunt for another vital resource, water ice. Hidden in the permanently shadowed craters at the lunar poles, where the sun has not shone for billions of years, are reserves of ancient ice. This ice is more than just a potential resource for future human colonies. It is a frozen archive of the solar system's history. Trapped within it are volatiles, gases and compounds, delivered by comets and asteroids over eons. By studying this ice, we can read the history of the cosmic bombardment that shaped the inner solar system, and perhaps even determine if the water in our own oceans was delivered by the same rain of celestial wanderers. Did Theia itself contribute to this reservoir, its own icy mantle vaporized in the impact and later recondensed in these cold traps? The answers are frozen there, waiting for us, and our quest extends even further. Advanced seismic networks to be deployed by future landers will listen to the deep interior of the moon, mapping its core and mantle with unprecedented precision. Just as geologists use earthquakes to understand our own planet's structure, these moonquakes will reveal the inner workings of our celestial partner. We will finally determine the size and composition of the lunar core. Is it small and iron poor, as predicted by a giant impact that primarily skimmed the mantles of both worlds? Or does it hold surprises that could once again force us to rewrite our models? We will create the first comprehensive geological and chemical map of the entire lunar surface, charting its history not just in space, but through deep time. The moon also offers us a unique platform from which to look outward. Its far side, perpetually shielded from the radio chatter of Earth, is the quietest place in the inner solar system.
That may be
it is the perfect location for a new generation of radio telescopes, instruments that could listen to the faint whispers from the universe's dawn, the so-called cosmic dark ages before the first stars ignited. From the surface of the world Theia created, we could gaze back to the very beginning of everything, using the moon as our silent, stable perch to unravel the deepest mysteries of the cosmos. It is a beautiful irony. The monument to our own violent birth could become the very lens through which we witness the birth of the universe itself. So when you next look up at the moon, whether it's a slender crescent or a brilliant full disk,
confirmed.
Allow
Level
yourself
stabilization
to see it for
at
what
40
it truly
hertz.
is.
The correlation
Do not
matrix
see a
is green
cold,
across the board.
dead rock. See a battlefield. See a memorial. See the surviving half of a planetary catastrophe that seeded the conditions for your own existence. See the cosmic anchor that holds our world in a gentle, life-sustaining embrace. That silver light cascading down is not just reflected sunlight. It is the ghost of another world, a shimmering echo of the fire in which our planet was forged. It is a constant, silent reminder that the universe is not a quiet or gentle place. It is a realm of unimaginable violence, of chance collisions, and of breathtaking creation. Our understanding will continue to evolve.
The correlation is clear.
New data from future missions will undoubtedly challenge our current theories, perhaps revealing that the Synestia model is itself just another stepping stone toward a deeper truth. The story of Theia and the formation of the moon will never truly be finished, because it is inextricably linked to our own. It is a story we will continue to tell, to refine, and to cherish, for in its dramatic, chaotic narrative we find the most profound reflection of ourselves. We are the children of that cataclysm. We are stardust, forged in the heart of a stellar furnace, assembled on a planet born from the collision of worlds, and now, finally, we are intelligent enough to look up and piece together the incredible, violent and beautiful story of how we came to be. The moon awaits our return, holding its secrets close, waiting for the next chapter in our shared cosmic journey to begin.